Question 5 is another one with interest rates, and this time it's money accumulating in a savings account. And we have multiple rates of interest, although we only have one payment at the very beginning. So this is not as complicated as it might be. We want EVA's balance on the 1st of January 2024. So starting at the beginning, 1st of January 2021, first we have this 0.415% per month. So you multiply by 1.00415 to the power of the number of months that is. January, February, March, 3 months. So we put that to the power of 3. And it's a monthly multiplier, and the exponent is the number of months, 3 months. Next we have for the rest of 2021, April through to December, and that's 4.7% per year. So the multiplier is 1.047. I should have mentioned how you get this number. Add 100 and divide by 100. So for example, the 0.415, you would say 100 plus 0.415 gives you 100.415, then divide that by 100 and you get 1.00415. And please don't guess if you need to write out the calculation. Now, this is not for an entire year. This is only from April through to December. So what can be quite useful is just to write the number of the month. April is the 4th month. December is the 12th month. If you forget the months, you have a computer in the exam, you can look at the Microsoft Windows calendar and see how many days are in each month if you need to, and what months there are in a year. Although hopefully you would know that. Now we are including the month of December, so it's not simply 12 take away 4, which would be 8 months. Because we're including up until the end of December, it's actually 9 months. You can count on your fingers if you want to. 4, 5, 6, 7, 8, 9, 10, 11, 12. That brings you to 9 months. This is an annual interest rate, so we put to the number of years. 9 months, 9/12ths of a year. And finally we have 2 years, 2022 and 2023. So that's times 1.026 to the power of 2. And just to, we do this on a calculator. We get £4,964.36 rounded to the nearest penny. And just to emphasise this point again, if it's yearly interest rate, you put the multiplier to the number of months. So if it's a monthly interest rate, exponent is to the number of months. Has to be consistent units for both. If it's a yearly interest rate, you put the multiplier to the power of the number of years, even if that is a fraction of a year. And that will be her balance for that question calculated. On part B, we are using the same interest rates, but it's a different person, different account, and we are told that he needs to finish after 2 years with £6,000. He's starting on 1st of January 2022, so we are using the 2.6% per year interest. And this is known as present value. In other words, how much would we need to save now to have a certain amount in the future? So let's think about this. If we were getting 2.6% a year interest, you would be multiplying by 1.026 every year, 2 years, so that's to the power of 2. we will finish with £6,000, and we want to know what we started with. Well, what's the opposite of multiplying by 1.026 squared? Dividing by 1.026 squared. So to get the initial amount, you take 6,000 divided by 1.026 to the power 2, and you get your answer £5,699.76. And that is your final answer.